Okay, so one thing that I guess if I immediately jumped out about 47, it's kind of hard to pick out a U. And this is where I say, and sometimes you just have to pick. If you think U is maybe this thing, then as soon as you do du, you're going to say, okay, well, this is what I get, and there's no way I'm going to make this stuff look like that stuff. So that's a bad choice for you. Well, in this one, I could see where you would maybe have trouble getting it started at first. But before you get into calculus, just use exponent rules. You can split apart a fraction, so we can integrate 5 over e to the 2x dx, and then subtract integrate e to the x over e to the 2x dx. Split apart your fraction first before you do calculus. Over here, this one reduces. Okay, and then I guess over here I would probably pick u to be 2x, du. We're going to probably have to do u substitution on both. So du would be 2 dx, but I want 5 dx. So I'm multiplying this side by 5 halves. So multiply this side by 5 halves. And I can rewrite this left integration as 5 halves 1 over e to the u du. And then this one, I'd probably rewrite this guy like that. You always want to do as much fraction, exponent rules, as much of that stuff as you can before you do integration. Same as derivatives last semester. Like before we took the derivative, if there was some fraction work or some exponent rules we could apply first, it usually makes the algebra easier. So in this one, I'd probably call u the negative x. So du is negative dx, negative 1 dx. So this guy can be rewritten as e to the u negative e to the u du. Now, what I did here is actually not very good mathematical practice. We shouldn't have u be one thing and then u be a different thing. So I'm going to be more mathematically correct, I'm going to call this v over here. It doesn't change anything, but we really shouldn't define u as two different things. So one of them's u, one of them's v. Okay. So over here, if I rewrite this, like that, well, e to the negative u would create a negative that I don't want. I guess I could have rewritten this before I did the u substitution. I wouldn't have to worry about that step. But e to the negative u is what's going to give you e to the negative u. So replace this back. Over here, the derivative of e to the v is what's going to give you e to the v. But plug in v again. And there's one thing that for sure can't be correct about this. Right, got to have the plus c. Now it's multiple choice. You know, they're always going to put the plus c and it doesn't seem like a big deal. But as a free response, you just lost 1 out of 9 points if you forget that plus c. So, yeah. Because of this negative here. When you take the derivative of e to the negative u, you would get e to the negative u times a negative 1. That's where I was saying up here, if I had rewritten this, if I had written this as 5e to the negative 2x, that probably would have been more ideal, because I'm really undoing one step of chain rule, and I don't want to undo any steps of chain rule if I don't have to, but I didn't write it just perfectly for the best u value. Okay, and I have no idea what I started with, it's too far up on the screen, but I am going to practice what I preach here by taking the derivative. So the derivative of e to something is e to something times chain rule, so times a -2. The derivative of e to something is e to something times the chain rule, will be times a -1. And the derivative of a constant is 0. So 5 over e to the 2x minus 1 over e to the positive x. And if I zoom out enough, that looks like what we were getting up here. So looks like it should be fine. But the one thing, I mean, the direction sounds a little different, but you're still doing the same stuff. And then 2, if you split it up into 2 parts, that's really the only way that u substitution is going to work. But makes the question longer because you have to do u substitution on the left side and v substitution on the right side. But if you can do those things, then give it enough time, it should be okay.